In this example, we're going to build a function that converts XML to JSON code. And before we get started, I want to point out that you probably won't need to do this in your everyday production work, but it's useful to understand the process. There's several good tools out there for working with XML and converting it to and from other formats, and we'll look at some of those in a separate video. All right, so let's go ahead and open up our code. We're going to open up XML to JSON in the Start Chapter 5 folder. And this is the business card data that we're going to be working on. So let's collapse that down so we have some more room. All right. To keep the example simple, the code that we're going to build is just going to work with the XML elements and the text. We're going to ignore the attributes for this particular example. You can do it. It's not that hard to add them, but I just want to keep this simple example, so we'll ignore the attributes for now. All right, so we're going to fill out this convert XML to JSON function. And you can see that I've already got some code that loads the XML document. And if we scroll down, I have some code here that hooks up an event listener to this button in the web page. So when the user clicks this button, it's going to call the convert XML function, which will load the XML document and then take that resulting document, pass it to our conversion function, and then that's going to give us a native JavaScript object back. And then we're going to call json.stringify, and I'll come back to that in a moment. And then that text content will be inserted into this pre-element right here, the one with the JSON container ID. All right, so let's go back up and fill out our function. So the code starts off with an empty JavaScript object, and the function takes the XML document to convert. So to process each element in the XML, I have to loop over all the child elements in the XML starting at the top. So I'm first going to check to see if the XML object's children property has a length greater than 0. And these are just some standard DOM properties I'm working with. So if, in fact, there are children elements in the XML object, then we've got some information to process. So then I have to have a loop, and I'm going to loop over all of the children elements. Okay. All right. So now I'm going to define a couple of local variables. First, I'm going to have the item variable, and that's going to be the current child element that we're looking at. So that's going to be the XML documents children. And I'm going to call the item function, the DOM function, to get me the current XML item. And then I'm going to have a variable called node name, which gives me the node name property. Again, that's a standard DOM property for that element. So for each element, I'm going to create a property on this native JavaScript object. So I first need to check to see if that's already been done, because remember, this is going to be a loop. If not, I need to create the new object's property and then process all the element's child tags. And that's a recursive process. So I'm just going to be calling this function again. So I'm going to check to see if the type of the property that's on the object of node name, if that's undefined, then I have to add the property. So I'm going to create the property on the object. So I'm just going to simply set the property at that point, and I'm just going to call convert XML to JSON on the current XML item. So the reason I'm doing this is because I need to convert each tag in the XML. So this has to become a JavaScript property, and then all the tags inside of it need to become sub-properties. So we're going to just rebuild this hierarchy using JavaScript notation rather than XML, and that's a recursive process, right? So otherwise, now if the property has already been added for this element, I have to check to see if there's multiple elements, because I'll have to create a JavaScript array, and that's how we'll handle the multiple phone tags. So what I'll do is I'll have an else condition. So if the type of the object's property at node name, so if that object doesn't have a push function, then that means the array has not been created yet. So what I'm going to do is define a temporary variable called current node, and I'm going to save aside the property that's already at that node. And then I'm going to replace the property that's at that index with an empty array. And then I'm going to restore the current node. So what's going to happen is as I run into each one of these phones, I don't want to have multiple properties named phone. I just want an array with all the phones in it. So that's what I'm doing here. If I come across a property that's already there, that means I have more than one. So now I have to create an array and push them all on there. And if that array has already been created, all I need to do is at that node name, I'm going to call push. And once again, because this is a hierarchical structure, I'm going to have to call XML, my conversion function again. All right. Okay, so now that takes care of looping over all of the child elements. Now, if there aren't any child tags for this element, I just have to get the text content and then add that to the object. So that is going to be my else condition down here. And I'm just going to write object equals XML obj.text content. So that's how we're going to access the names of each node and the text that's inside of each node. And once that's done, I just return the finished object. Now, when this function returns, what I'm going to do is I'm going to have a JavaScript object, but I need to convert that to text. So I'm going to call the stringify function on the browser's JSON class, and that will convert the object into a string. It takes some arguments. So it takes the object I want to convert, and then a custom formatter, which I'm not using, so that's going to be null. And then it's going to just give me one line. Otherwise, if I don't specify a number here, this is the number of spaces to indent each line in the JSON code. So let's go ahead and save. And let's bring this up in the browser. And let's click the button. And you can see that when I click the button, sure enough, the XML is converted into the JSON code. In the previous example, we saw how to convert XML to JSON data. And XML can also be converted to and from a variety of other formats. Now, the good news is that there are a variety of tools available to help with this process. So I'm not going to make you do any more conversion coding. There are some very good commercial tools available for working with XML, and I'll just list a few here if you want to check them out. First is Altova XML Spy. It's been around for many years. It's a very popular tool for working with XML, JSON, and other data formats. There's also Oxygen XML Editor. It's another tool. It's been available for many years. And again, it can work with all kinds of data formats and XSD and XQuery and JSON and so on and so forth. A third tool I personally have had some good experiences with is called Liquid Studio XML Editor. And you can find that at this link. And I'll give you one other coding library that's open source. If you need to work with XML and JSON in code as we did in the previous example, there's an open source package called XML.js, and you can find that at this link. And you can see it's very popular. It gets, millions of downloads per week. You'll need to have Node.js installed in order to use it from the command line. And you can also use it in the browser in your own code. If you want to try it out yourself, you can follow the installation instructions. I'll scroll down just to see those really quick right here. So you can follow these instructions to install it. And remember, you're going to have Node.js installed if you don't already have it. Now, I've already done that. So I'm just going to go over to VS Code and try this out. So here in the code, I'm going to open up my terminal, and let's make this full screen so we can see what's going on. Okay, so to make sure that it's installed correctly, what I'm going to do is just type the XML-JS command in the terminal. And when you do that, you can see the tool gives me a list of usage instructions. So it appears to be working correctly. All right, so I'm going to give this a try on the business card XML file that we've been working with. So to do that, I'm going to write XML-JS, and then I'm going to give it the source file that I want to convert. That's businesscard.xml. And then I'm going to use the --out parameter to name the output file. And that's going to be businesscard.json. And then I've got some options I can specify. So for example, you see this option right here, -- compact. That will give me compact JSON form, which is easy to read. So I'll just go ahead and specify -- compact. And if I don't do anything else, it will give me JSON all on one line, which is hard to read. So I want to have it indented like we saw in the previous example where we wrote our own code. And to do that, I'm going to use this option, the spaces option. So I'll write -- spaces, and I'll give it a number of spaces. Let's use 3. And then I'll just hit enter. All right, and when I do that, you can see over here that businesscard.json has been created. So let's minimize the terminal, and let's open it up. All right, and if we look at the code, you can see that the XML has been converted to JSON, including the XML declaration. There's an option, by the way, to exclude that if you don't want it. But here's our root tag. Here's the name element with the text inside of it. Here's our array of phone numbers. And you can see that in this case, unlike our code, the attributes actually got converted into JSON code. And there's the email. So if you need to convert XML to JSON, I would suggest first investigating one of these tools before you go off writing your own code. A little earlier in the course, I talked about some complementary technologies for working with XML. One of those is XPath, which is what we're going to cover in this chapter. XPath is a W3C standard for accessing data in XML. It's a pretty fundamental part of some other XML technologies like XSLT, which we'll look at a little later, and XQuery and some others. Essentially, XPath provides a way to query and extract information from XML content by using path-like expressions. And you can think of this as being similar to a way that directory paths work in a file system. If you're interested, you can learn a lot more about XPath and how it works at this URL on the W3C's website. What I'm going to do in the rest of this chapter is just give some practical examples for how XPath works, and then we'll take it for a spin, and we'll even use it in some web pages. Probably the best way to see what I mean by defining a path into a document is to look at a few real examples. So let's take another look at our business card XML that we've been using. Now, suppose we wanted to get a reference to the top level business card tag right here. Using XPath, I would define a path into the XML content by writing something like this. And that essentially means starting at the root of the XML file, which is what that first / means, then look for a tag named business card. If I wanted to refer to the name tag, I would write the XPath expression like this. Suppose we wanted to get references to these 3 phone tags. Now remember, in file systems, file names have to be unique within a given directory, but that's not true in XML. You can have multiple tags of the same name under the same parent tag. So in this case, I would write /businesscard/phone. That would give us a reference to all 3 phone tags. If we only wanted, say, this phone tag, the first one, then we would modify the path expression by putting what's called a predicate expression at the end of the path inside square brackets. A predicate expression lets me use a logical condition to determine whether to select a tag. And in this case, I'm going to add a bracket with the number 1. Now, this may be a little bit confusing if you're used to other programming languages where arrays are indexed using 0 as the starting number. XPath is 1 based. So this expression /businesscard/phone bracket 1 would give me the first phone tag. Let's review some important XPath concepts, and then we'll take it out for a drive, because actually using XPath is probably one of the best ways to learn it. XPath has a very compact syntax, and it's pretty quick to learn. The path expression is a series of what are called location steps. So for example, in the previous slide, when I wrote /businesscard and then /name, each one of those is a location step through the document. There's also something called the context node, and this is where the path evaluation starts from. And in some of the more advanced scenarios using XPath, you can change the context node to be wherever you want in the XML. Now, I'm not going to get too deep into that here, but you should just be aware that it's possible and that it is essentially the node where you start evaluating the path from. There's also the notion of an axis. The axis is the relation between the context node and the nodes that are selected by the path. So you start at the context node, you end up at the selected nodes, and then that path between the two is called the axis. Another term to be familiar with is predicates. And I showed an example in the previous slide when I put that little bracket with the 1 on the paragraph tag to narrow down my selection. Predicates are further refinements to the selection process. You can think of them almost as like a filtering method. All right, so let's take a look at some XPath examples, and then we'll take XPath out for a spin. So the first is the slash character, and that path expression simply says, hey, select the root tag in the document, whatever it is. The next example, where it says slash root tag, also selects the root tag, but only if it happens to be named, in this example, root tag, but it can be whatever name you want. The next example with 2 forward slashes means select all the elements named tag name, regardless of where they are found in the document. So I don't have to specify the exact path to it. It just means, hey, search the document, and if I had tag name elements scattered throughout the file, this would get all of them. It's like a global search. The text function selects the text content of the current node, which I can then use, for example, to compare to specific values. The @ symbol selects the attribute of the current node with a given attribute name. And 2 periods means to select the parent of the current node. All right, let's take a look at some more advanced examples. We already saw how to use an index as a predicate value to get a particular tag. In this case, the second phone tag, right? So we have business card phone bracket 2. If I wanted to get the last phone element and I didn't know how many there were, I could use the last function to do so as part of the predicate. So in this case, I've got slash business card slash phone. And then inside the brackets, I've got the last function, so it just gives me whatever the last tag of that type is. I can use the @ symbol to get the value of a particular attribute. In this case, I can get the phone tag that has an attribute value of mobile. And I can get pretty fancy with this. In this case, I'm getting the phone tag whose text starts with the string 212. And you can see that this expression actually matches 2 of the phone tags in this XML. So this should give you a little bit of an idea of how powerful XPath can be while still remaining relatively simple to write. But again, probably the best way to learn this is to actually take it out and use it. So let's do that in another video. Okay, let's use what we've learned about XPath so far and take it out for a spin on some sample XML data. I'm going to be using a free online tool for this called XPather, and you can find it at this link, xpather.com. It has a very simple user interface. Right here at the top is where you enter your XPath expression you want to test. This text area here contains the XML code to test against, and the area to the right over here contains the result of the XPath expression. Tools like XPather give you a way to try out your XPath expressions in an interactive way so that you can quickly test different expressions before you use them in your production code. So let's use the XML code that contains multiple business cards as our example. So I'm going to select all of this content and blow it away. And then over in VS Code, I'm going to select the code that's in business cards.xml. So I'll select all this and copy it, and then go back over to XPather, and I'll paste this in here. Okay. And then let's get rid of this XPath expression up here. Okay. So for our first expression, let's try something simple. Let's write an expression that gets all of the business card elements that are inside the root element. So I'll write slash, and I'm going to write business cards. And you can see as I'm typing, the UI is updating in real time. So when I write slash business cards, you can see that the entire file got selected. And then I'll write slash again, and then I'm going to write business card. Okay. And when I do that, you can see that all of the business card elements are now selected, and the results are over here in the right-hand side. And as I mouse over, right, we can see that each result is highlighting the corresponding XML that goes along with it. All right. So if I just want to select a specific card, I can use the predicate syntax to supply an index value. So inside my brackets, I'm going to write the number 2. And you can see that when I do that, so the first one is skipped, and now the second business card is selected. And if I want to get specific parts of the business card, I can then add those to the path. So let's get the person's name. So I'm going to write /name. And then when I do that, you can see that now only the name tag is selected here in the business card. All right. Now, notice that this expression selects the entire element, right? The entire name, including the text. If I just want the text content, I can use the text function. So I'll write another slash, and then I'll use the text function. And now you can see that I'm just getting the text. Suppose I wanted to get the name on the last business card, but I don't know how many cards there are. Instead of using the integer index, I can use the last function. So let's replace 2 with last. And you can see that now the name in the last business card is being selected. So let's try working with some of the attribute values. Let's select all of the phone tags in the entire XML that have a type attribute equal to mobile. So remember, we can use the double slash to do that. And I'm going to select all the phone tags. And you can see that that's when I type //phone, right? Every phone tag matches that. But now I'm going to use a predicate expression to only select the phones that have a type attribute equal to, and then in quotes, I'm going to put the word mobile. And you can see that when I do that, now only the phone tags that have the type attribute equal to mobile are now selected. So now let's select all of the primary phone numbers, right? You can see that there's a primary attribute on some of the phone numbers. What I'm going to do is I only care if that attribute exists. So what I'm going to do is get rid of all this and just type @primary. And when I do that, it doesn't look for a specific value. It just simply sees, hey, is there an attribute named that? And if so, it gets selected. All right. Let's narrow this down further to only select the primary phone numbers that start with an 800 area code. So in this case, I need to use 2 predicates in order. So the first one is going to select the phone tags that have the primary attribute. And then I'll have another predicate next to this one. So I've got 2 predicates in a row now. And I'm going to have this predicate test to see if the text content of the tag starts with 800. So in this predicate, I'm going to use the starts with function. And then I'm going to see if the the text content starts with the string 800. Look at that. So now notice that this primary phone number is no longer being selected. It's only the ones that are starting with the string of 800. Okay, so we're getting pretty fancy here. Let's try something similar. Let's only select business cards where the name contains the letters DO. So let's get rid of this. And you can see that the business cards, like some of the names have, like this one's John Doe, that's got a DO in it. This one has a DO in it. This one has a DO in it. So let's go ahead and write / business card. And the predicate is going to be where the name element, and I'm going to have another predicate for contains, and I'm going to see if the text contains the string DO, and I need to close off my predicates. And sure enough, right, now notice how I'm filtering on the content of a specific piece of text, but I'm selecting the entire business card. And that's what predicates allow you to do. They allow you to specify these almost they're query-like conditions, right? It's like I'm querying the XML for, hey, look for the name that contains this text and then just select the card. You can get really pretty powerful with this. So this should give you a good sense of the kinds of things you can do with XPath. We'll be visiting XPath again when we get to the section on XSLT later in this course, because XSLT uses XPath to select the nodes in your XML that it works on. But you can use XPath by itself in JavaScript, and we will see how to do that in a separate video. Now that we've seen how to use XPath to extract information from an XML document, let's try using it within the web browser to work on some XML data. To use XPath directly in our web pages, we need to use the evaluate function, which is supported by all modern browsers. It lets us evaluate XPath expressions, and you can see here in the MDN documentation, it works on both HTML and XML documents, so that's kind of nice. And you can use it alongside the DOM functions that we learned about earlier in the course. The evaluate function takes 4 parameters. The first is the XPath expression to evaluate as a string. The second is the context node, which is the starting point from where the expression should be evaluated from. The third argument is a namespace resolver, and that's actually pretty rare to use, so we're not going to be using it. And finally, the last argument is the result type that we are looking for. And you can see that there are several possible values for this parameter. We're going to be using the first one, which is any type, which basically means whatever type most naturally results from the XPath expression. The evaluate function will return an XPath result object. So let's take a look at that documentation. So this object contains a variety of properties. But if we scroll down, we'll see that it has an iterate next function, which is what we will use to process all of the XML elements that are returned by this expression. So I'm going to go over to our code. Here in the code, I'm going to open up in the Chapter 6 Start folder, the XPath inspect example. And this is pretty much the same example that we saw earlier in the course from the DOM API chapter. In this case, I'm going to use XPath to select the name and email from the businesscard.xml file, right, which we saw earlier. And just like we did in the DOM chapter. So I have a button in my web page, which will show the business card data. And when that button gets clicked, you can see that I'm loading the business card XML file and then assigning the result to this global variable up here. And then the show card data will display an alert containing the name and the email, which is essentially what we did earlier in the DOM chapter. So I have 2 strings for my XPath expressions into the XML. So let's write the code to get the data. What I'm going to do is declare a result variable, and I'm going to call document.evaluate. And I'm going to pass in the name expression, which is this XPath expression string here. And then the business card XML data is what we'll be operating on. The third argument, the namespace resolver, just pass null for that. And then for the XPath result, I will pass in XPath result dot any type. All right. So that will give me the result of this expression. And then what I'll do is I'll declare a variable called name, and that's going to be my name string. And I'm going to call on the result object. I'm going to use the iterate next function to get the name element from the business card. And I need to get the text content out of that node, right? So if we look at the XML data, right, this gives me the entire name, and what I want is the string that's inside of it. And then I'll do the same thing for the email. So I'll just copy and paste this. And in that case, I'll be evaluating the email expression instead. And then the string is going to be email. And I'll call this email. All right. So that will give me the name and the email. So let's go ahead and save this. And let's bring this up in our live server in the browser. And I'll click Show Business Card Data. And sure enough, you can see that we get the alert, similar to what we got in the DOM chapter, showing me the name and the email address. And you might be thinking to yourself, well, that's pretty cumbersome compared to just using the DOM. And you're right. For a simple example like this, XPath doesn't add a whole lot of value, but let's take a look at a more advanced example. Let's go back to the code. I'm going to close this, and I'm going to open up the XPath build example, which is pretty much the same as the DOM chapter example where we built HTML content from multiple business cards. Now, using XPath, remember, I can create complex XML queries. And if we scroll down, right, you'll see that we have the Create Business Card element button, and we have this empty card container div, which is where we're going to put the business cards. So when this button gets clicked, we're going to call Create Card Element, and that's this function here. So we're going to load our XML document, and then using the resulting XML data, I'm going to use some fairly complex XPath expressions to filter the content that I'm going to put into my document. All right. So the first XPath expression defined looks for business cards where the primary phone number starts with the string 800. And we saw this earlier when we were doing the exercises with XPather. So let's evaluate that using JavaScript. I'll create a result. And once again, I'll call document.evaluate. And inside the evaluate function, I'm going to pass in the expression, which is this string right here. I'll be operating on the XML data that we just loaded right here. I'll pass in null for the namespace resolver because we're not going to use it. And once again, for the result, I'll just use any type. Once we get the result back, we need to iterate over the XML nodes that are returned in the XPath result object. So I'll make a new variable called node, and I'll call result.iterateNext. And then I'm going to have a loop. So while I have a node to operate on, we're going to add content to the document. So the code for creating a div to hold the business card is the same. You can see that I left the code from the DOM example intact. So we have the same code for creating the name section and the email section. So I'm going to do exactly what I did in the DOM chapter. I'll make a new card variable, and I'm going to create, oops, not an attribute, an element. And I'll create a div to hold the business card. And we'll set the CSS class to the business card CSS class. And then we'll create the name and email sections. So I'll create my name section from the node that I'm working on. And then we'll append that. All right. And then we'll do the same thing for the email. So this will be the new email section. And we're going to create the email section there. Okay, so we've created the new name and email sections. Then we add the newly created div element that holds the business card information to the card container. So I need to get the element by ID, and that's going to be the card container. And I need to call append child with the new card. And then we just advance to the next node. So now we have node equal to result.iterateNext. All right, so we're going to process all the nodes that come back from the XPath result. So let's go ahead and save this. And let's bring this up in live server. All right, let's go ahead and click the button. And sure enough, you can see that only the cards that have a primary phone number that starts with 800 are listed. Now, you can't see the phone numbers, but you can go ahead and verify this on your own. Let's change the expression. So let's go back to the code. And instead of using this expression, I'm going to comment this one out. I'm going to type control/, and I'll control/ and uncomment this one. So I'm going to uncomment the expression that looks for names that start with, or well, that contain the text string DO. And again, we saw this earlier in the chapter when we were using XPather. So in this case, we're going to try this example live. So All I'm going to do is just change the expression. I'm not going to change anything else. That's the only part of the code I'm going to change. So I'm going to save that, and let's go back to the browser. And now you can see that we've refreshed. Let's go ahead and click Create Business Card Element. And now you can see that we're only creating business cards with names that contain DO. So we've combined the power of the DOM API with the ability of XPath to perform complex queries on our XML and building HTML content out of that. All right, it's time for another programming challenge. In this challenge, you're going to use XPath to build an HTML file that contains the XML data from our business card dataset, which is very similar. In fact, it's the same from chapter 4 when we learned how to use the document object model. So that's going to be this dataset right here. For that earlier challenge, we built HTML to represent all of the business cards in the XML dataset. Now, this challenge is going to be slightly different. We're going to use the querying capabilities of XPath to selectively choose the XML data to put into the web page. So I'm going to run my finished example so you can see what it looks like. So this is the completed solution. So I have two buttons in my web page. One is labeled Create Primary Work Cards, and one is called Create Example.org Cards. So when I click on the Primary Work Cards button, you can see that only two cards appear in the HTML. And that's because these two cards are the ones where the primary phone number is the work phone number, which we can see when we look at the XML data. So if we go back to the code really quick, we can see that in this case here, we have the work is primary and work is primary. So we've got Jane Doe and Jim Doe, right? So we have those two cards. So when I click on the example.org button, in this case, there are also two cards, and you'll notice that both of these cards have an email address that ends with example.org instead of example.com. Again, if you go back and look at the XML data, you'll see that the other two cards have example.com in them and they don't show up. So your challenge will be to implement the code that uses XPath to select the correct cards from the XML data and display them in the web page. Now, I've given you a starting point for the code, so let's go back to that. So this is the starting point, and you can see that I left some of the functions from the previous challenge in the file that are used to create the HTML from the XML data. And you can choose to use these functions if you want to, but it's not required. I just wanted to give you a starting point that you could decide whether you want to use. And if we scroll down a little bit more, you can see that I've already connected the two button elements to the create card elements function, which loads the XML and then calls create biz cards, which I've left in place, which resets the body of the web page each time one of the buttons is clicked. I've also put a couple of comments where your code will need to go. Now, I realize this particular challenge is one of the more difficult ones we've had so far, so don't worry if you don't get it on the first couple of tries. Remember, the objective here is to learn. I will give you a hint that you're going to need to use predicate expressions in order to filter the XML data and only select the XML tags that are relevant for each button. Another hint I'll give you is that you'll need to investigate the XPath function named contains, which checks to see if a string contains another string. So take some time, try the challenge out, and then refer back to the chapter material if you need to, and then I'll be back to explain my solution. All right, so how did you do? This particular challenge was a bit of a tricky one, so don't worry if you had some difficulties in completing it. Okay, I realized it was a little on the challenging side. So let's take a look at my code. The way that I chose to approach this problem was by first figuring out the XPath expressions I would need in order to query the XML. So I'm going to scroll down. What I did was we needed to select the business cards where the work phone number was the primary phone number, right? And so to do this, we needed two predicate expressions. one to detect the presence of the primary attribute on the phone tag, and another to check to see if the value of the type attribute was equal to work. So that's this expression right here. You can see that on line 106, my XPath expression does just that. It uses the double slash operator to find all of the business card tags where the phone tag has a primary attribute and the type is equal to work. For the second part of the challenge, our XPath expression needed to select business cards where the email address ended with example.org, and that's this expression here. So that's two expressions, and the way I chose to implement this was by having each one of the button elements call the create cards function, which gets passed to the create biz cards function when the XML gets loaded. I call this function with the expression I want to have evaluated. So that way, the expression is specific to that button. That gets passed along to the function that creates the cards. And that way I've kind of parameterized it so I can, change it in the future if I want to. So if we look up at the create biz cards function, it's very similar to the one in the previous challenge. All I'm doing now is I'm also passing in an expression to evaluate. So that expression gets evaluated. I use the document.evaluate method to run the XPath expression. That then gives me an XPath result. So I iterate over each node using iterate next until there are no more business card tags. And then I just call the existing functions I already have in place to create each section of the HTML and put that into the document using the technique we saw earlier in the chapter. That's pretty much all there is to it. Like I said, I know this challenge was a bit on the harder side. So if you had some challenges getting it done, take some time to understand my solution and then compare it to your own code. In this chapter, we are going to investigate XSLT, which is a way of applying templates to XML data. XSLT is one of the complementary technologies that you can use to work with XML that I mentioned at the beginning of the course. It builds on using XPath, so if you haven't yet watched the chapter on XPath, I suggest you watch that first. XSLT stands for Extensible Style Sheet Language Transformations. It's similar in principle to CSS, but it's a little bit different in practice. You might see that word style sheet in the name and think that XSLT is used to give a visual appearance to XML. But the more important word you need to focus on is transformation. CSS essentially applies a set of styling rules to content in either HTML or XML files, and we've already seen that. XSLT works by applying templates and logic to XML data, and we'll see how that works later in the chapter. XSLT is also written in XML syntax, so when you look at an XSLT style sheet, it's written using XML code, whereas CSS is written using its own unique format. XSLT is pretty powerful. It can transform XML data into almost anything else, such as another form of XML, or PDF, or Word, or even HTML. XSLT can also perform logical operations directly on the data. So things that might take time working with the DOM, for example, generating numbered lists or sorting information, that can just be done pretty easily directly in XSLT. XSLT is a pretty complex subject and could probably fill an entire course just on its own. So in this chapter, I'm going to focus on the basics. You can always learn more by going directly to the W3C website at this URL to learn more about XSLT. So let's learn a little bit about how to create these XSLT style sheets. They're defined using the XSL:"style sheet root tag. They also typically contain one or more XSL template tags, which contain the definitions for the templates, and we'll see how that works in a little bit. Templates are then matched to XML tags in the source XML data. So given a source XML file, the template is applied against it. The template then figures out which of the XML elements in the source data that it applies to, and then the template goes and does its work. So usually, the contents of the template replace the source XML and transform it into whatever the output is. But templates can also contain other XSLT directives. You can do things like loop over content, sort data, create new content in the output, and we'll see examples of all those later in the chapter. In addition to being matched to source XML data, templates can also be invoked by name, almost as if they were a function. Let's take a look at how XSLT works conceptually. You provide an XML document. This is where your source data comes from. Then you create an XSLT style sheet that you want to apply to your XML data. Each of those is then supplied as inputs to an XSLT transformation engine. And this engine can be found in several kinds of places. Modern web browsers have the ability to operate with XSLT, but there are also server-side implementations that do this as well. So if you're doing any back-end server work, you can take XML and XSLT content and transform it on the back end before the resulting data is sent to the browser. The output of this is a result document which contains the transformed XML into whatever you transformed it into. Another XML format, a PDF file, Word. It can be almost anything. So next, we'll learn about some of the various XSLT template directives you can use to transform data, and then we'll see XSLT in action. Before we get started writing our own XSLT style sheets and trying them out, I'm going to review some of the more common XSLT elements, explain how they work, and then just show a really quick example. The first is the style sheet tag. This is how you define an XSL style sheet. Next is the template tag. The template tag contains either a match attribute, which is an XPath expression, and determines how the template is matched to the content in the source XML data, or it has a name attribute. Templates with a name attribute can be called as if they were functions. Then there is the XSL value of tag, which also uses an XPath expression and is used to select data. It can be text, numerical, whatever the data content is in the source XML file. This is how you extract data from a matched tag in the source data. You can also insert output into the transformation stream by using tags such as XSL attribute and XSL text. This will generate content that is placed into the output file. In addition to tags for matching and inserting content, there are some control tags. So for example, there's a for each tag that can be used to loop over repeating items in an XML file. You can use XSL if to perform if-else comparisons. And by now, you're probably looking at this list and saying, oh, wow, this really is different from CSS. And yeah, you're right. In addition to XSL if, you can use the choose when and otherwise construct, which is similar to a switch case construct in other programming languages to perform more advanced calculations and logic. And then finally, you can use the sort tag to select data for sorting content in the output stream. Now, this is not a complete list of all the tags. There's plenty of others, but these are some of the more common ones, and they're the ones that we'll be focusing on in the rest of the chapter. We're going to be seeing examples of using each of these throughout the chapter, but for now, let's take a look at a really quick example. So to define a style sheet, I use the style sheet tag and give it the XML namespace with the XSL prefix and using the URL that you see there. Then I can define a template. And in this case, I have a template with a match attribute that matches the root tag of an XML document named simple tag. So remember from the earlier chapter on XPath that this path syntax is how we specify which tag we're interested in. In this case, the / means I'm looking for a root tag, and then the text there, simple tag, means I want a root tag named simple tag. Inside the template, I define the HTML code I want to replace the XML content with in the source XML document. So this style sheet is taking XML and transforming it into HTML. And I could just as easily transform it into text or anything else. But in this case, I'm transforming it to HTML. And then to insert content from the source XML into the HTML, I would use the value of tag. In this case, the text content of the matched simple tag root. And whatever text is contained within that simple tag is going to be inserted into the resulting HTML here inside what looks like an H1 header. So that's a pretty quick example of how you define a style sheet. Next, we're going to actually take XSLT out for a spin and see it in action. Let's take what we've learned about XSLT so far and try a simple example. So I'm going to open up simpletransform.xml in my Chapter 7 start. And this file is pretty simple. It only has one XML tag and there's some text in the tag. Let's also open up simpletransform.xslt. And we'll come back to this. This is the style sheet that we're going to build that's going to match the Java code T tag in this XML file. So first, right at the top, we have our style sheet declaration. This tells the style sheet parser that this is an XSLT style sheet. Then I have a template definition. The template uses an XPath expression to match this template with content in the source XML file. So in this case, the match expression says, start at the root of the document, which is that /, and then look for a tag named Java code T. And sure enough, if you look in the XML, that's what we have. We have the root tag and it is named Java code T. So when the match takes place, the contents of this template are going to be evaluated and substituted in the resulting output in place of the original Java code T tag. Now, before we can do that, we need to associate the style sheet with the XML file. So to do that, we're going to add a line of code under the XML declaration in our source document. And there are other ways to do this, but I'm just going to show the simple way first. So I'm going to insert the XSL style sheet, and the href is going to be simpletransform.xslt. And I'll leave the type as text/XSL. So let's save that. All right, so let's go ahead and make sure live server is running. I'm just going to go ahead and open this with live server. And okay, here's our folder. We'll go into Chapter 7 and click on Simple Transform. And you can see that the XML file has been transformed into HTML. Now, currently, all I'm getting is this image right here. And if we go back to the code, we can see why. So in the code, I've got this image right here that's being inserted into the HTML document. And that's pretty much it. What I would like to do is insert the string that's inside the Java code T tag into the HTML. So to do that, I'm going to use an XSL value of tag. So I'll put a H1 in here. And then I will put in a XSL value of. And then the select is going to be the text function. All right. So the select attribute of this tag contains the XPath text function, which means get the text content of the tag we are currently working on. And that is this Java code T tag right here. So because this template has already matched this tag, then the context within it is that we're working on this tag. And so I can just use text to get the content out of it. So let's go ahead and save this. And let's go back to the browser. And if we refresh, right now you can see that the text content of the Java code T tag is being inserted into the HTML result. Now, what's funny is if I do a view page source on this, right, it's not the HTML that we transformed into. It's the actual original XML, which is to be expected, right? Because that is in fact the source. But if I actually bring up the developer tools on this resulting page right here, okay, you can see the resulting HTML code. This is not the XML code. So you can see that the HTML that was created as a result of the transformation. And this really helps when you're trying to debug. But that's it. That's your first simple XSLT style sheet. Let's examine some of the more powerful parts of XSLT by working with repeating sets of data. So I'm going up to open up the repeating items XML file. And in this XML file, I have a root tag named items. And under items, I have 4 item tags that represent products for our Java code T company. So each of the item tags contains some product information, such as the name, product type, a URL for the photo, and the photos are contained in this directory right here. Each item also has an attribute indicating whether it is currently available. So let's open up the repeating items XSLT file. So here we have our style sheet declaration and our template. The template is going to match the root items tag. And the template is generating some HTML content. What I'm going to do is use the for each tag in my template to build up an HTML structure for each of these items elements. So I'll add that code here. And what I'm going to do is put in XSL for each. And then I need to have a select attribute. And the select is going to be item. So why is that? Well, remember, the context is now, we've matched the items structure, right? So we've matched this. And now we have a for each loop that's going to operate on each one of these item tags. So I'm going to add the rest of the code. And what it's going to do is I'm going to build up a structure that includes an image and some text from each item in the XML. So let's go ahead and add that code. I'm going to wrap everything in an H1. And yes, I'm clearly not a graphic designer. Inside the H1, I'm going to put an image tag. I'm going to do it this way because I need to specify some attributes on the image tag. And to do that, I have to have this structure where inside the image, I need to specify my XSL style sheet stuff. But don't worry, in the finished output, it will be an empty image tag. So I'm going to put in XSL attribute. And I'm going to add an attribute named source for the image. And that attribute is going to contain, I'm going to use value of, and it's going to be the value of, and I'm going to select the photo. So if we go back and look at our XML, right, you can see that each item has a URL to the photo. So I'm adding a source attribute to my image whose value will be the URL inside that photo tag. All right, I'm going to keep on going. So I'm going to put in another value of tag. And this time I'm going to select the name. And oh, whoops. There we go. And then I'm going to put in some text, just some raw text. I'm going to put a colon and a space. And then I'm going to use value of, and in this case, it's going to be equal to the type. All right. So you might be wondering why the select expression of this photo tag, right, and the others don't contain a full path down to the photo. That's because we're using a partial XPath selector to operate on what's called the context node. So in this particular case, the for each tag is operating on each item, which we've already matched against in our top level items tag. So this means I don't have to keep on specifying the full path down to each one of these tags just to operate on them. It automatically knows that, hey, this photo, this name, this type, it's contained within this item tag here. All right. So let's go ahead and save. And what we're going to do is bring this up in the browser and see what it looks like. We got to bring up the XML in the browser. There we go. So let's go ahead and open this with our live server and start. We're going to go to chapter 7 and click on repeating items XML. And sure enough, now you can see that we're looping over all the items inside the XML. So we have all the photos, and then we have the contents of the name tag and the type. So we've got some candles, a teacup, a couple of teapots, and then the name of each product. So working with repeating items in XML and XSLT is pretty straightforward and easy using the for each element. One of the more powerful capabilities of XSLT is the ability to apply style sheet templates based upon the values of the incoming XML data. And that's what we're going to look at in this example. So let's open up conditional logic XML and conditional logic XSLT in our start folder. So this is the same XML data we've been using from the previous examples with our Java Code T products. And here's our conditional logic XSLT file. It should look a little familiar to you by now. It starts with our template tag and it matches against our items. And this is the for each tag, which I introduced in a previous example. So what I'd like to do is apply a different visual appearance to items that are available from those that are out of stock. And if you scroll up, you can see that I have a style sheet defined here in my HTML. And I have a no and yes class for my H1s based upon whether or not a item is in stock or not. So the color is going to be different. So to do this, we need to apply some conditional logic to the data that's coming in from the XML. So I'm going to add some code for that. I'm going to add an XSL if tag, and I'm going to have the test be that the attribute named available is equal to no. All right. So the XSL if tag allows me to specify a test condition. And if the test is met, then the contents of the XSL if tag are applied in the template. So here I'm testing to see if the attribute named available is equal to no. And back in the XML data, you can see that we've got no's and yeses. Okay, so some of these products are available and some are not. So in this case, when the available attribute is equal to no, then we're going to apply the contents of this template. So I'm going to move my HTML from here inside the XSL if. All right. So now I'm going to add another conditional test for the yes case. So I'll do the same thing, XSL if, and the test is going to be if the available attribute is equal to yes. And if it is, I'll have the same contents applied. And the difference is going to be that in the no case, I'm going to apply the class equals no to this H1 and class equals yes to this H1. All right, so let's go ahead and save everything. And now let's bring our source document up into the browser. So I'll open this with our server. And in chapter 7, we'll go to the conditional logic XML file. And sure enough, you can see that the items whose attribute is no are grayed out, while the ones that are available are shown in color. That's pretty cool, huh? You can use conditional logic in your style sheets. So let's try something a little bit different. Let's go back to the code. Let's open up conditional logic 2 and conditional logic 2 XSLT. And we'll close the previous examples. So sometimes if you have a lot of different conditions you want to check, writing XSL if over and over again is not really what you want to do. All right. What I'm going to do is use a different conditional logic structure called the XSL choose element. And it's useful when you have a bunch of choices to choose from. So let's go ahead and put that in. I'm going to put in XSL choose. And then I'm going to have my conditions. So I'm going to use the XSL when tag. That also has a test. And I'll see if available is equal to no. And for that case, I will put in my H1 tag. And so this is going to be, the class is going to be equal to, let's see, what do I have here? So I've got unavailable, soon, and available. All right, so when the available attribute is no, actually, is that the correct ones we're using? So we've got no, yes, soon, and yes. Okay, so for no, we'll have unavailable. And then I'm going to have another one. All right. So when the test is yes, the class here will be avail. Oops, got to spell that correctly. And is that correct? Yes, it's avail. All right. So now I have two when conditions. And I want to have a condition that's applied when none of the other when conditions are met. All right, so we have in our data, we have no, yes, and soon. So I'm going to add one more condition, only in this case, I'm not going to use XSL when, I'm going to use an XSL otherwise clause. So that's going to be XSL otherwise. And then I'll just paste in my code, and I'll make that the soon case. And we don't need the when. All right, so let's go ahead and try that. All right, so let's save that. And now let's bring our code up in the browser. So let's go to the live server. And once again, in chapter 7, now we'll do conditional logic 2. And you can see now that we have multiple conditions, right? So this is a no, we have a yes, we have a soon. So this is how you can use the if and the choose tags to incorporate conditional logic into your style sheets. We can use XSLT to sort our XML data. So I'm going to open up the sorting XML and sorting XSLT files. The sorting.xml file contains the same XML content we've been using. So this is our product for Java Code T. And you can see here in the sorting style sheet, this is the same XSL style sheet from the previous example where we had the choose and when tags. So I've already got my for each tag and I have my choose and so on. What I'm going to do is sort the data, and all I need to do this is use the XSL sort tag. And this is really easy. All I have to do is add it right below the for each tag. So I'm going to put in my XSL sort, and then I need to select the data that we're going to sort on. In this case, I will sort on the available attribute, and I'm going to make the order descending. And that's pretty much it. That's all I have to do. Okay, so I've got my XSL sort tag. I've got my attribute I want to sort on. And that's pretty much it. So let's save this. And let's bring the sorting up in the browser. So let's open this with our server. And in chapter 7, we'll do sorting. Okay, so now you can see that we have the yeses, the soons, and the nos. Okay, so that's the descending alphabetical order on whether or not the items are available. Let's try sorting on something other than the available attribute. Let's go back to the code. So let's go to the sorting style sheet. Instead of sorting on the available attribute, let's change that to the name of the product. So I'm going to put the name tag in here. And you can see that each of these, right, each item has a name tag. So I'm selecting the name tag. And then let's try ascending order this time. So let's save. And let's go back to the browser. All right, and then let's refresh. And now you can see that, sure enough, we're sorting on the product name in ascending order. So that's really all you have to do. Inside your for each tag, put the sorting tag, and you can sort your data without having to write any programming logic. The examples that we've worked with so far in this chapter have been standalone XML files. In this example, we're going to use XSLT to transform XML directly in the client-side browser using JavaScript. So let's open the client transform XML and the XSLT source files. So the XML data is the same product data that we've been working with, and the XSLT style sheet transforms the XML into an HTML table element. It's not a full HTML structure, right? It's just the table. So we're going to take this result and put it into our HTML file. The table will display the item photo, the name, and the product type for each item in the XML. The table body section is being built using a for each tag, which we learned about earlier. So this loop builds a table row for each item element in the XML source data, and each row contains 3 table cells: an image, the product name, and the product type. Now, so far, this should all look familiar to you based on the work we've done up to this point. So now let's look at our HTML files. Let's open up the client transform.html file. So I have a script section that we will fill out. All right. So my script has a couple of functions. So I have my load XML document function, which uses the fetch API to load the files at a given URL. And it gets the text content and uses the DOM parser to parse the text into an XML document object. And this function is used in the load products function twice. So you can see that I'm loading both the XML source data and the XSLT style sheet using my load XML document. And remember, my XSLT, it is XML. It's just a style sheet defined using XML syntax. So once both documents are loaded, I need to process them using an XSLT processor to create the resulting HTML table that's going to go into the document. And if we scroll down a little bit, you can see we have this div right here, which is currently empty. This is the div that's going to hold the finished table once it is built. So let's go ahead and jump over to the MDN documentation for a second, because I'm going to create something called an XSLT processor. And if we look, you can find the documentation for XSLT processor at this link. This is a standard JavaScript object that enables you to perform XSLT transformations. All right. So I'll let you read the documentation for the class on your own time more closely. But if I scroll down to the browser compatibility section, you'll see that it's widely supported across all browsers. All right. There are two functions that I'm interested in. So let me scroll back up. Okay, so here is the instance methods. So the first is the import style sheet function, which associates an XSLT style sheet with the processor object. And then there's a function called transform to fragment, which creates a piece of HTML that I can then add to my document using the DOM functions that we learned about earlier in the course. So let's go back to the code and finish this, and we're going to use these functions to do so. All right, so let's go back to the source code. All right. So the first thing I need to do is create an XSLT processor object to process my transform. So I'm going to create a processor, and that's going to be a new XSLT processor. Okay. And then once I've done that, I'm going to import the style sheet that I just loaded. So I'm going to call processor dot import style sheet. And that's going to be this variable right here where we load the style sheet. All right. Okay, so now I need to perform the transformation. So I'm going to call transform to fragment. And I'm using transform to fragment because I'm not creating a full HTML file. I'm just creating a piece of HTML. So I'll create a variable called list, and I'm going to call processor dot transform to fragment. I'm going to transform the XML that I've loaded. That's this variable right here. And I'm going to do it within the context of the current HTML document that I'm working in. That's going to be the new owner of this fragment, and that's important. And then I'll just return the list. All right. So the result of this function is going to give me a piece of HTML that I'm going to add to my document. And you can see that I'm going to trigger this process when the window loads. I have my function that's going to fire on that event. I'm going to call load products. And then when that's done, I'm going to have this resulting document fragment that's going to get appended into the div with the ID of product list. That's this div right here. So I'm going to call get document by element ID. That's going to give me this div. And I'm going to call append with the list that I just created. So let's go ahead and save this. And let's open this with our live server. And sure enough, you can see that when the document loads, I get this nice table, and you can see the resulting table of products here in my web page. So just by using about 10 or so lines of JavaScript, I was able to take XML and XSLT and produce an HTML result that we can now include directly in our web page. It's time for an XSLT-themed programming challenge. For this challenge, you're going to build a style sheet that transforms the data in this business cards XML file. And you can see it contains multiple business cards, and it's going to be transformed into an HTML page that lists the information from each business card in a table. So let me show you what the result is going to look like so you know what you're going to build. So I'm going to go into my finished folder, and I'm going to open this in the live server, and that's going to be this business cards. All right, so this is the finished result. You can see that the HTML page contains two things. One, it's the number of business cards that there are. So that's part of the challenge you're going to have to build. And there's a table that contains the data from each one of the business cards. So there's the name, there's the primary phone number, not all the phone numbers, just the primary phone number, and the email address in a table. And the table is sorted in ascending order by the value of the name. All right, so that's what you're going to build. And I've already provided a starting point for your XSLT style sheet. So let's open that. So here in the code, I'm going to close my finished folder. If you look at challenge start XSLT, this is the style sheet that you will need to build. And this is where you'll have to display the card count. And this is where your code is going to go to build the body of the HTML table. Okay, so you can see we're creating a full HTML document here, so you won't need to do the browser-based transform we saw earlier. All right, so take what you've learned so far in this chapter and go ahead and get started on that challenge unless you want a couple of hints. If you want the hints, keep watching. You ready? Are you sure you want the hints? Last chance. Okay, here they are. So let's go over to the browser. So the first hint is that you're going to need to look at the XSLT's or XPath count function. And this is how you're going to get the result for the number of business cards. All right, so look into how count works. The second hint is that you're going to need to use the for each tag to loop over each business card. And of course, you will need to use the XSL sort tag to sort the data. All right, so go ahead, take a crack at that challenge, and then I'll review my solution. All right, how did you do? Were you able to get the list of business cards into the HTML page as a sorted table with the count? Let's review my code. So remember, we needed to count the number of business cards and put that into the title of the page. So let's open my code. And this is my finished XSLT style sheet. So to do the counting, we needed to use the count function, and this is one of the hints I gave you, along with the value of tag to put the number of business card elements into the page. So you can see here that inside my H1, I'm using the value of tag, and I'm selecting the count of business card tags, right? So you can see I'm matching against the root business cards, right? This is the root of the file, the root of the XML data, and I'm counting all the business cards, and that's how I got the count of how many business cards that there are. Then we needed to extract certain pieces of data from the XML and build an HTML table. And the top part of the table was already done. So to build the table content, my code uses the for each tag to loop over all the business card tags. And I'm going to build a table row each time. And of course, I had to use the XSL sort tag inside my for each in order to do the sorting. So I'm sorting on the name ascending. So that was how we solved that part of the challenge. So each row has a table cell in it that uses the value of tag to extract, in this case, the name, the phone number that happens to have the primary attribute attached to it, and the email address. So that's pretty much all you needed to do to solve this challenge. Take a few moments to compare my code to yours and see where they're similar and where they're different. Earlier in the course, I mentioned that XML could be two things, well-formed and valid. Up to now, we've already seen how to make well-formed XML content, where the data follows all the syntax rules so that it can be successfully parsed. In this chapter, we're going to learn how to ensure that XML content is valid in addition to being well-formed. And the way you do this is you associate a set of rules with your XML content to help ensure the quality and make sure that the XML data is as error-free as possible. One way to do that is through what are called document type definitions, or DTDs. They provide a way to constrain the content of an XML document so that you can specify what kinds of tags, attributes, and other types of content are permitted. You can specify what kind of content is allowed, where it can appear, and what values the tags themselves can have. DTDs can be included directly in an XML file, so it's a self-contained unit, or they can be declared as external DTDs and then associated and reused with more than one XML file. DTDs are pretty simple to write, but the trade-off is that they're not very flexible or powerful. You can specify some basic rules, but XML schema, which we will look at in a separate chapter, is a lot more comprehensive. Now, that doesn't mean that DTDs aren't useful. In fact, they're probably best suited to XML structures that aren't very complex and don't require a lot of rules. So why would you use a DTD? Because, as we've seen so far in the course, they're not required. We can work with XML just fine without them, and we have been. The main reason is that if you're taking your XML content and you're giving it to third parties, or if you have a complex process that consumes XML, it's always a good idea to make sure that the XML content is valid and follows your rules. DTDs help make that possible. You can give your DTD out to the consumers of your XML, and when the parser loads the XML, it will compare your rule set with the content so that errors can be found quickly. Certain kinds of XML tools, like XML editors, can also use DTDs to help you create XML content so that errors won't be introduced while you are in the creation process. So let's revisit our business card XML and consider some rules that we might want to apply to the content. So for example, we might want to enforce that the name tag is required and that there should be only one. After all, a business card isn't very useful if it doesn't tell me who the person is. We also might want to allow multiple phone numbers, but we want to make sure that the type attribute is limited to one of home or work or mobile. And finally, maybe we want the email tag to be optional, but if it's present, then there's only one. So this is actually going to be the programming challenge later in the chapter. So as you're going through the rest of the chapter, be on the lookout for ways you can enforce these rules on the business card when we get to the challenge. Now that we've learned what DTDs are, let's take a look at their syntax and try our hand at writing one. DTDs contain markup declarations that define document content. In other words, they lay down the rules for what an XML document can and can't contain. There are two ways to associate a DTD with XML content. The first way is to just embed the DTD directly inside the XML itself. You can do this by creating a doc type section at the top of the XML and specify the name of the root element, which is then followed by the rules for that content. The second, and much more common way, is to create an external file that can be reused by other XML documents, and we'll see how to do this later in the chapter. DTDs can specify a variety of document content rules involving elements, attributes, entities, notations. Well, I'm not going to read the whole list. You can see it for yourself. In other words, DTDs can specify just about every kind of XML content type that we looked at earlier in the course. Now, those last five, from entities down through parameter entity references, are pretty fairly advanced. So for the rest of this chapter, I'm only going to focus on DTDs that define elements and attributes because those are by far the most common examples you're going to find when you're working with DTDs. And if you want to, of course, you can head over to the W3C website and read all you could ever want to about DTDs. I'm going to keep this as simple as I can and just focus on the elements and attributes. All right, let's consider an example. And for that, we're going to go over to our VS Code. All right, so here in VS Code, I'm going to open up my products.xml file, which is in my start folder for chapter 8. And this is a XML dataset that has some products in it. So each product has a name and a price along with attributes that indicate whether the item is in stock and what currency the price is in. In the next couple of videos, we'll learn how to define the DT rules for this content, so take a moment and get familiar with it. Let's start by declaring elements in a DTD. Declaring elements inside a DTD is accomplished using an element declaration, and these have the format of an angle bracket, followed by an exclamation point and the capital word element, followed by a name and a content specification. The name field is the name of the element that you're going to be declaring, and the content specification defines what the valid content for the element is. Elements can have one of 4 different types of what are known as content models. First is the empty content model, in which the element has no child elements at all. No text, no tags, nothing. A good example of this is the image tag in HTML or the horizontal rule tag and so forth. These tags don't have anything inside them. Next is the any content model, which is the opposite from empty. This means the element has no content constraints whatsoever. It can contain pretty much anything. Then there's the element content model, which means that the element can contain the child elements that you list for the content specification, but that's it. You can't put other elements that are not inside the content specification inside that element. And then finally, there's the mixed content model, in which the element can contain both other elements and character data. So let's take a look at some examples of these different types of content models. So first we have an element named miscellaneous, and it has the keyword any, which means that the miscellaneous element can contain anything. There's no limit on what could be inside. It could be other elements, text, whatever. An empty element declaration would look like this. Here we're defining an element named image, and then the keyword empty goes at the end, which means it has to be empty. There's no content inside this element at all. To allow character data content, we use the keyword PC data with a hash in front of it inside parentheses. PC data means parsed character data. So in this case, the element name is allowed to have character data inside of it. Now, you might be wondering if there's a way to define an element that has a CData section in it, which is unparsed. And the answer is, remember, the CData tag itself is in fact parsed. It's only the text content inside the CData section that is unparsed. So there's no way to specify that an element can contain only a CData section. Just a little bit of trivia there. Element content means that the element in question can have other elements inside of it, and there's a couple of different ways to do this. The first is the sequence model. So in this case, we have an element named CD, which can contain a title and an artist tags. And it's interesting to note here that what this means is that the CD element has to have exactly one title element, and it has to have exactly one artist element, and they have to appear in that order. If you wanted them to appear as a choice, you would define the element content using a choice model. In this case, we have a dwelling element, which is using a choice model. And inside the parentheses, we have 3 different elements that are valid for the dwelling element. So inside of dwelling, you would find either an element named house, or one named apartment, or one named trailer. And these element names are separated by the vertical bar character. So what this means is you're allowed to choose one of these elements to appear in there, and only one is allowed. There is a way to specify how many of a certain element is allowed to appear, and we'll cover that in just a moment. To define mixed content, you would use the PC data keyword, which we saw earlier, with the vertical bar, and then any other elements that you would like to be allowed inside the element you're defining. So that last example there, we're defining an element named title, and the title element is allowed to have parsed character data inside of it, as well as one subtitle tag. In this case, it doesn't really matter where each one appears. You can have them in any random order. So let's go back to the problem of specifying how many elements are allowed to appear inside an element you're defining. To modify the element declaration to indicate how many elements you'd like to have, you can use certain modifier characters to control how many elements can appear. And these characters are the question mark, the plus, and the star symbols. So if you put a question mark next to an element name, that means 0 or 1 of those elements can appear. So it makes the element optional. It's either there or it's not. A plus sign means there has to be at least one of the elements, but there could be more. And then a star means there could be 0 or more of the elements. So for example, this element declaration defines a letter element, and inside the letter element, you can have 0 or 1 A elements because of the question mark, followed by 0 or more B elements, followed by 1 or more C elements. So the plus sign, that means there's got to be at least one, but there could be more. All right, so let's use what we've learned to define some rules for our product list. Let's go over to VS Code for this. All right, so I've got my products XML file open, and I'm going to open up my products.dtd file, and I'm going to fill this out. So first, let's define the top level element. So to do that, we have an angle bracket with an exclamation point, and I'm going to create an element. And the element is going to be called product list. And that is going to be containing one or more product tags. All right. Then let's create a rule for the product element. So element named product. And the product element has to have a name and price elements, one of each. And then finally, let's add the name and price element definitions. So I'll have an element for name, and that is going to consist of parsed character data. And the same thing for the price. Okay, so now we've defined our DTD. Let's save that. Let's associate our XML with the DTD. So what we need to do is in the products file, down here, we're going to put in doc type. And the doc type is going to be, oh, actually, you know what? Hang on. That's the inline definition. So I'm going to declare doc type, and it's going to be for the product list. And then I'm going to use the keyword system, and then I'm going to refer to products.dtd, and I don't actually need the full path there. All right, so this is how you associate the DTD with the XML file that you're working on. And when I do that, you can see that the rules are being applied to the XML content. Now, we're still not done, because you can see that we haven't defined the in-stock and currency attributes yet, and we'll tackle those in a separate video, right? But if I try to remove the name, right? So you can see that I get this little red squiggle underneath the product name. It says, hey, the content of element product is incomplete. It must match name and price. So now that rule is being enforced. So let me undo that. And I'll do the same thing with price, right? I'll cut that. And you can see that the error shows up again, right? So I'll undo that. And you can see that because we haven't defined attributes, which we will, but we haven't done that yet. So we're getting these errors saying, hey, in stock must be declared for element type name. So we have some basic error checking for our XML, and we will add the attribute support in another video. All right, we've seen how to declare elements. Now let's declare some attributes. Declaring attributes in a DTD is accomplished in much the same fashion as declaring elements. So all attributes you're intending to use in a document that's going to be validated by a DTD have to be declared via an attribute list declaration. And an attribute list declaration looks like this. It has an opening angle bracket with an exclamation point, the capital word ATT list, and that is closed by a closing angle bracket. And the element name is the name of the element that you're defining the attribute to be used on. The attr name is the name of the attribute. The type is the attribute's type, and I'll get to those in a moment. And the default declaration defines how the attribute behaves under default situations, and I'll get to that in a bit. The attribute type can be one of three types. There's the string type, which is indicated by the CData keyword, which is all capitals. This means that the attribute can be any literal string, and you can just type in the value for the attribute. The enumerated type means that the attribute can come from one of several potential values, but any other value would result in an error. And then there's the tokenized type. The tokenized type is reserved for things like IDs and ID references and other advanced features of DTDs. I'm not going to go into that here because it's a little bit advanced. I'm going to cover the string and enumerated types because, once again, these are by far the most common examples you'll run into when declaring DTDs for your XML files. The string type is declared like this, and in this example, we're declaring a status attribute for a package element. In this case, it's a string attribute because of the CData keyword. The default value is in the quotes there at the end, and it's defaulting to OK. So what that means is if you don't define the status attribute on an element in an XML file, and you request the value of that attribute using the DOM API, it will still have the default value of OK, just as if you had typed it into the XML data and put it there yourself. Now, of course, because it's a string type and there are no other constraints on it, you could put other values in there as well. But this is a way of telling the XML processor that if a certain attribute is not included, then there's a default value. An enumerated type looks like this. In this case, we're defining an attribute for a dwelling element, and the type, which is the name of the attribute, can be one of the following inside the parentheses separated by those vertical bar characters. And that's pretty similar to how you define a choice type of an element declaration. So in this case, the type attribute for the dwelling element can be either house or apartment or trailer, right? It can't be a mobile home or a condo. Those would be invalid attributes. The default declaration is a way of defining not just default values, but how the attributes should be viewed by the processor. And there's a couple of ways you can modify the default declaration. There's the required keyword, which means that the attribute has to be included in the XML data. There's the implied keyword, which is indicated by the word implied. And in this case, the attribute for an element is optional. There's also the default value, which is the value to use for the default. And then there's fixed, which means that the value's fixed at a certain value. So in this example, we have an attribute named onTime, and onTime is required. Use the required keyword there, and it can either be yes or no. In this case, we have an onTime attribute, and it's either yes or no, and it's implied. In other words, the XML markup may or may not contain it. And then in the third example, here the onTime attribute for the package element is character data, and it's fixed to the value of yes. If you put anything else in there, that would be an error. Okay, that's a lot to take in. So let's take what we've learned so far and go back and complete the DTD for our product list example. And I'm going to switch over to the code. All right, so we only have two attributes we need to handle. There's in stock and currency. So I'm going to add definitions for both to my DTD, and I'm going to do that using the enumerated type. So I'm going to create an @list, and I'm going to use the @list on the name element, and it's going to be called in stock, and it's going to be either true or false. And I'm going to specify that that's going to be required. And then I'll create another attribute list. And this is going to be for the price element. And the attribute will be named currency. And currency can be either US dollars or Canadian dollars or euros or Japanese yen. And that will also be required. All right, so let's save this. And now when we go back to our XML file, you can see that everything is fine now. The errors have disappeared from the in-stock and currency attributes. We've got no red squiggles anywhere, so that's good. If I try to change in-stock to anything other than true or false, like if I type, blah in here, you can see that that immediately results in an error because I have to have a value from the list true or false. So let's undo that. And then similarly, the currency attribute has to be dollars, euros, or Canadian or Japanese yen. So if I try to specify, say, Swiss francs, okay, that's also an error. And you can see I have to have one of the values from that list. All right, so now we've completed our DTD, and now we can check for basic errors in our XML data. Okay, I said it was coming. Here's the programming challenge for the business card DTD. So we're going to take what we've learned about DTDs and build a DTD for our business card for this challenge. So here's the rules that we discussed earlier in the chapter. So the business card root element can only contain name, phone, and email tags. The name tag is required, and there can be only one. There should be at least one phone element. There can be multiple, but the type attribute is limited to being home, work, or mobile. The email tag is optional, and there can be at most one of these. And then finally, the DTD needs to be an external file that is referenced in the XML content. All right, so you're going to go ahead and give this a try. Let's go ahead over to the code really quick because I've given you a starting point. If we look in the starting point for the challenge, this is the business card you're going to be using, and here is the DTD that you are going to be filling out. So go ahead and give that a try, and I'll be back to explain my solution. Okay, let's take a look at my solution to the challenge. So this is the business card XML file, and you can see that I've added my doc type definition here at the top of the file using this processing instruction for the business card DTD, and the DTD is contained in the business card DTD file. So let's open that up. So you can see that my DTD contains the various rules that we had to implement. So first is the rule that defines the business card itself. That's here at the top. And it can contain other elements. In this case, it contains a name element. And you can see that it's required. It's got to be there. So there's no modifier on it. It can contain phone elements. And because of this plus sign, remember, that means one or more. And then there's the email element, which has the question mark modifier, which means that the email element is optional, but if it's there, there can only be one. All right. So next are the content elements themselves. So the name element can have character data in it, and the phone element also can have parsed character data in it. And in addition, the phone element has a required attribute named type, and that type has to have a value of mobile, work, or home. And then finally, we have the email tag, which can have parsed character data. All right, so now that we've written the DTD, let's try validating our document. Remember, you'll have to have the Red Hat extension installed for this because that's the extension that's processing this DTD. So here in my business card file, let's try adding a tag that isn't part of the definition. So let's put in company. So you can see right away we get an error that says element type company must be declared because it's not in the DTD. And we get an error saying, hey, business card is now wrong because it doesn't say that this is allowed. Okay, so that's good. All right, let's try taking that out. Let's try removing the name element. All right, so that results in an error because now business card is no longer valued. There's got to be at least one. So let's undo that. Okay, let's remove all of the phone elements, right? That results in an error too. Okay, let's remove all but one. Okay, that's fine. So we have to have one or more. That's good. Let's try removing email. Okay, that's good because remember, it's optional, so there's no error. All right, so far, so good. Okay, let's try changing one of these type attributes to something else. Okay, there's the error. It's got to be mobile, work, or home, so that's good. All right. Okay, so the DTD validation appears to be working, and you can see that by using DTDs, you can help prevent errors from being introduced into your XML data and find them if they happen to make it through anyway. In this chapter, we're going to look at another way of enforcing rules and constraints on your XML data called XML schema. XML schema is an alternative to using DTDs, which we learned about earlier in the course. Schema allows you to constrain your XML content just like document type definitions do, so in that way they're similar. Schema files are written using the same XML syntax that you use to write your XML data, so this is in contrast to DTDs, which use their own custom syntax. DTDs are kind of like XML, but they don't really follow XML formatting rules. XML schema is much more powerful than DTDs are and much more flexible. They allow a finer level of control than DTDs provide you with. So, for example, recall from the previous chapter, we talked a little bit about how it's possible to generally control how many elements can appear inside of another element by using special characters. But there was no way in a DTD to specify that an element can only appear 4 times within another element or constrain the value of an attribute to match a specific pattern. In Schema, you can easily do things like this. Now, of course, all this power comes with a price. Schema is a little harder and usually more verbose to write than a DTD, but it provides a much finer level of control. And unlike with DTDs, where you have the choice of defining a DTD inside your XML data or storing it as an external file, schema definitions are always stored separately from the XML content. And the result is XML files that are far less likely to violate rules or slip through the cracks than would be the case with using a DTD. In this chapter, we're going to go through the same process that we did in the DTD chapter. We're going to explore how we can declare element and attribute rules, and then we'll take a look at how we can define a schema for the business card example that we've been using throughout the course. Let's take a quick look at the structure of an XML schema file. Schemas use the namespace that you can see here at this link. Now, that's not an actual link you can go to. That's just the namespace definition. And usually, schemas use the XSD namespace prefix. And recall, we talked about namespaces a little earlier in the course. We saw them in action when we went through the XSLT examples. A schema definition typically begins with the XSD schema tag, and you can see that I have that here. And then inside the schema tag, that's where I would put my element and attribute definitions. So for example, I could define an element using the element tag. And you can see here in this example, I've got an element I'm declaring named root_elem. And then I would put any other content inside my element that went along with that element. So for example, and we'll get more into this, so don't worry about it. Example, I could put an attribute tag in there, and that would indicate that my element has an attribute with a specified name. Now, this is a pretty simple example, and things can get more complex depending on how much control and what kind of constraints we want to put in place on the XML data. In the rest of the chapter, we'll go through some examples and learn more about the level of control that Schema gives you over declaring rules for your XML content. Let's see how to declare simple elements with Schema. Schema is a fairly complex subject that could probably fill an entire course just by itself, so I'm not going to go into every possible feature that XML Schema provides. However, by the end of this chapter, you should know enough to be able to generate some fairly sophisticated schema definitions to validate your XML content. As I said earlier, elements are declared using the element tag in the schema file, and elements can be declared as either having a simple or a complex type. So for this example, we're going to focus on simple types. These types can either be built-in schema types, or your schema file can define your own custom types, and we'll see that in a little bit. So just like in DTDs, you can declare elements that have mixed, empty, or element content. Elements can also be given a minimum and maximum number of times they are allowed to occur. And so remember, you can kind of sort of do this with DTDs, but for example, you can't specify an exact number of times that an element is allowed to occur. But Schema solves that problem. There are just a couple of attributes you need to set that controls how often an element can occur. Elements can also be restricted to having certain values, and this is where Schema really begins to show its advantages over DTDs. Schema provides a set of built-in simple types, so let's take a look at some of these. Now, I'm not going to go through every one of these, but you can refer back to the table as you need to. So right at the top is the string type, which is the sequence of characters of allowable XML characters. There's also types for Boolean, decimals, and integers, and they start to get a little bit more specialized, such as the positive integer and negative integer types that restrict content to numbers that are either larger or less than 0. There's a type called any URI, which restricts content to being a URI format. And there's some more specialized types to represent data like dates and times, as well as various components of dates, such as days and months and years. Okay, let's take a look at a couple of examples of declaring elements. So here we have two elements. So the first one declares an element that has the name of my element, and its type is a string. And the second one defines an element name of hire date, and that one has a type of date. So when you declare these in your schema file, the corresponding XML content would contain elements named my element and hire date, and they would be restricted to having, in the first case, string content, and in the second case, they would have to match the format for a date. You can limit how many elements appear in an XML file or inside a particular XML element within that file by using the min occurs and max occurs attributes. So each of these attributes is optional. The default value of these is 1. So just like in DTDs, if you don't define these attributes, it's assumed that the element can appear at minimum once and at most once, so you can have exactly 1. In the first example, there's an element I'm declaring named friends, and it has a type of string, and it has a min occurs of 1, and it has a max occurs of a special string value named unbounded, which means there's an unlimited number of these tags that could appear in my XML data. So here in this next example, there's an element named phone that's also a string type. And in this case, there is no min occurs attribute, so it's assumed to be 1. The max occurs attribute is set to be 5, which means we can have a minimum of 1 and a maximum of 5 elements. You can also define your own custom simple types. You do this by deriving them from the simple types that are built into schemas. So let's take a look at an example. Suppose we had an element in our XML data named invited guests because it represents data for a party event. We could just specify the type of this tag as a positive integer. But the problem with that would be that a positive integer allows you to specify a value all the way up to, a really large number. And I doubt we're going to be inviting the entire planet to our party. So we probably want to provide a much more tight restriction on the number of invited guests. So inside the element, we would use the simple type tag. And then inside there, we would use the restriction tag to declare that our element is restricted to having certain content. In this case, we could specify a restriction based on the positive integer type. And inside the restriction, we would use two tags, min inclusive and max inclusive. Each of those is assigned a value, 0 and 50. Min inclusive and max inclusive define a range. In this case, it's a range of allowable values for the number of invited guests. So the word inclusive means that those two values, 0 and 50, are included in the allowable range. So any value between 0 and including 0 up to and including 50 would be allowed for the invited guests element. If we didn't want to include the 0 and the 50, instead of using the min inclusive and max inclusive words, we would use min exclusive and max exclusive. You can also restrict content to allowable choices, and this is something very similar to what we saw in DTDs. In this case, suppose we have an element named dwelling, and we want to restrict it to a number of allowable choices. Inside of the simple type tag, I would place a restriction, and in this case, I'm going to restrict it based on the string type. And instead of using the min and max inclusive, now I'm using these enumeration tags to enumerate the allowable values for the dwelling tag. And here I've got values such as house, apartment, and trailer. So the XML data is allowed to contain one and only one of these choices for a dwelling tag. But it gets better though. You can actually restrict content of elements based on patterns using what are known as regular expressions. So let's take an example where we have an element named SSN that represents a social security number. And again, we're using the simple type tag here to declare our own custom type, and we're using the restriction tag. In this case, however, the restriction is a pattern, which is specified here by the pattern tag. The value attribute of the pattern tag defines a regular expression. And if you're not familiar with regular expressions, they are a way of writing strings that define a pattern of characters that are allowed to appear for a given value. So basically, this pattern means that the content for the SSN tag is restricted to a string that matches the pattern of 3 digits, followed by a dash character, followed by 2 digits, followed by another dash character, and then followed by 4 digits. And that's the pattern that fits a US social security number, and any value supplied in the XML data for this type would have to match that pattern. So you can already see that schema is much more powerful than DTDs are. All right, let's try out what we've learned so far on a simple example. So here in my start folder in chapter 9, I'm going to open up simpletype.xml. And you can see that there's a single tag named mySimpleType that contains a string of text. And I have the namespace definition for the schema, as well as an attribute that specifies where the XSD file is, which is currently, it's the same directory as my XML file. So this is how you specify that. And you can see that we already have an error. And that's because the parser can't find a declaration of element mySimpleType. So we need to go fix that. Let's go build the schema file to validate this example. So I'm going to open up simpletype.xsd. All right. And we have a starting point right here. I've got my schema tags already defined. I'm going to add a definition for my SimpleType element that's allowed to have text content. So I'm going to add XSD, and it's going to be an element. And the element name is going to be my SimpleType. And the type is going to be XSD string. All right, so let's save that. And now when we go back to the XML file, we can see that the error is gone, and that's because my SimpleType contains text. But watch what happens when I change the schema definition. If I change this to be, say, XSD integer and save it, oh, now we have an error, right? So we go back, and you can see that the error, now the squiggle is not on the element definition like it was for DTDs. You can see that the error is directly on the text. And the reason it says that is because the parser is now expecting an integer and not these non-numeric characters. So if I change this to be an integer, well, you can see that the error goes away. Everything's now fine again. So this is how you can enforce your XML content to be constrained to certain types of values.